Hey everyone, welcome to TitanClass. On this episode of TitanClass, we've got a whole bunch of complex numbers. Part 1, adding and subtracting complex expressions. Part 2, multiplying complex expressions. We've got some dividing, definitely rationalizing, definitely complex conjugate. And then we've got powers of I. So let's get started. Just like last time, I've got 50 problems for you. Hopefully this won't take too long. Part 1. Adding and subtracting. Number 1, 7 minus 2 plus 6i plus 5i. Okay, the minus sign here has to distribute to both terms. So this is going to be 7 minus 2 minus 6i plus 5i. All right, both i's are going to combine, and the 7 minus 2 will combine. So this is going to be 5. And that's a negative 6i plus 5i, which is negative I. It is in the form of a plus bi, so our answer is good. And then we've got number 1, 5 minus I. Number 2. Negative 5 plus 8i plus 4 plus 8i. Okay. Two binomials linked together with a plus sign. We do not distribute plus signs, so we're just going to drop the plus signs and the parentheses and move from there. All right? So this is going to be negative 5 plus 8i plus 4 plus 8i. Negative 5 plus 4 is negative 1, and then 8i plus 8i is 16i. Ooh. See, I said 16 and wrote 61. That doesn't make any sense. Right? So plus 16i. And again, it's in the form of a plus bi, so we're good to go. Number 2 is negative 1 plus 16i. I figured I'd be a little off on that one. Plus 16i. You can see that. And I'll move over next time. All right, number 3. Negative 5 minus 3i plus 4 plus, this is weird, 4i in parentheses. Okay, so again, we've got a couple plus signs that are linking things together. We're just going to drop everything down and the parentheses go away. Only minus signs distribute, right? So this is a negative 5 minus 3i plus 4 plus 4i. Negative 5 and 4 again is negative 1, and negative 3i plus 4i is plus I or plus 1i. Final answer here. So number 3 is negative 1 plus I. All right. Rolling right along. Plus signs are pretty easy to deal with. You're not going to see too much trouble when it comes to those. We will obviously get to minus signs shortly. 5 plus negative 3 plus 2i plus I. And again, I don't know why the program's putting these i's in parentheses, but it doesn't matter either way. Again, all plus signs, going to rewrite. 5 plus, or 5 minus 3 plus 2i. The reason I don't like the double sign is because that's really garbage in mathematics. So this is really just a plus negative 3 or just minus 3. Same thing, plus I. So we've got 2 plus 3i is the final answer. So number 4 is 2 plus 3i. Can you hear the dog barking? He's been kind of annoying this afternoon. All right, so we got our first subtraction problem. 7 plus 4i minus 4 plus 2i. Okay, so I was really high up. Okay, minus signs in front of parentheses means distributive property. So I'm going to distribute that negative sign, and I'm going to have to get him after this, to both the 4 and the 2i. So this is 7 plus 4i minus 4 minus 2i, right? So we are changing the signs of both of those terms. Now I can combine like terms. 7 minus 4 is 3, and 4i minus 2i is plus 2i, right? So our answer for number 5 is going to be 3 plus 2i. And you can see all of our answers are in the form a plus bi. 6 plus 5i minus 7 minus 7i. Okay, again, just like the last problem, we are distributing the minus sign in the middle. 6 plus 5i minus 7 plus 7i. Combine like terms. 6 and negative 7 is negative 1. And 5i plus 7i is 12i. So number 6 is negative 1 plus 12i. Okay. Number 7. 2 minus 4i plus negative 4 minus 7i, okay? Back to the plus sign, we do not distribute plus signs, so we just drop down a level and drop the parentheses. So 2 minus 4i, it's gonna put a plus minus, that's no in mathematics, right? So this is just a minus 4 minus 7i, right? Combine like terms, 2 minus 4 is negative 2, and negative 4i minus 7i is negative 11i. So number 7 is negative 2 minus 11i. Okay. Number 8, 2 more like this, and then we're going to talk about some conjugates actually. Kind of falls into the same area, I guess, a little bit. Okay, this is a messy one. Distribute the minus sign, changes both of those to pluses, right? And then we just drop the parentheses down. Remember, when you distribute the minus sign, it does nothing to the first set, right? The first set stays the same. This is gonna be a plus 8 plus 6i. Now we can combine like terms. Negative 4 plus 8 is 4. But take a look at what happens with the 6i's. Negative 6i plus 6i is 0. So the answer to number 8 is just 4. Number 9. 7 plus I, and that's in parentheses, minus 4 minus 7i. Okay, same deal. This is a little weird in the front though. You might see that. Distribute the minus sign to both terms, gives me a 7 plus I minus 4 plus 7i. 7 minus 4 is 3, and I plus 7i is 8i. So final answer for number 9 is 3 plus 8i. All right. Number 10. And again, this is the last one in the set of adding and subtracting. 2 minus 3i minus 3 minus, yes, negative 6 plus 7i. Okay, a lot of steps here, same process. That minus sign belongs to that 3. There's no distributive property needed. That minus sign, however, distributes to both of those terms, right? So because that minus sign here is directly in front of that parentheses, it's got to distribute. That minus sign does not distribute because it just belongs to the 3. So let's drop everything down and see where we're at. 2 minus 3i does not change. The minus 3 does not change. But this is going to be a positive 6, and that's going to be a minus 7i. Now I'm going to combine like terms. When you get more than like 3 or 4 terms here, it might be a good idea to start underlining stuff and like boxing and circling if you need to. 2 minus 3 is negative 1. Negative 1 plus 6 is 5. And then I've got a negative 3i and a negative 7i. Combining those gives me a negative 10i. So final answer here for number 10 is going to be 5 minus 10i. Okay. Now that wraps up the adding and subtracting portion, but I'm going to stay in this section because the next 5 problems are conjugates. Okay, so I'll leave that up there. No, I want to stay with it. So we'll erase these 10, and then we'll start off with number 11. Okay, so the next part is complex conjugates, right? We'll make this part 1A because it wasn't actually in there. So remember that the complex conjugate is really just the opposite sign that links things together, or if it's a single term, it's just the opposite sign. So number 11 asks us, what is the complex conjugate of 7i? Okay, well, if that's a positive 7i, the complex conjugate, or the conjugate, is just the opposite sign. So for number 11, we've got a negative 7i. Number 12, what is the complex conjugate of negative 3i? Well, again, it's just the opposite sign. This is a single term. So the complex conjugate of negative 3i is positive 3i, right? 13, what is the complex conjugate of negative I? It's supposed to be tricky. It isn't. It's just I, right? Because again, I'm just changing signs. Now, number 14 and 15 are going to be actual two-term binomials. What is the complex conjugate of 3 minus 3i? All right, well, I just changed the sign in the middle. I don't do anything to the outer signs, right? So number 14, the complex conjugate is 3 plus 3i, right? That's all I'm doing. And then number 15, negative 6 minus 7i. Okay, so again, it's trying to trick us, but it isn't tricky at all. The complex conjugate is just plus in the middle. That negative 6 stays negative 6. So this is going to be negative 6 plus 7i, done deal. All right. So remember, conjugates are just the opposite sign if it's a single term, or the sign in the middle changes if it's a double term or a two-termed. Okay, pretty simple. Let's move to section 2, or part 2, and that is multiplying complex expressions. All right. I want to pick up here, right? 16. 6 plus 3i times negative 2 plus 4i. Okay, now a giveaway in terms of whether you know it's adding or subtracting or multiplying is that there is no sign linking these two things together, meaning the parentheses are literally right up against each other. When there's no sign in the middle and they're right like this is multiplication, because this is just the rules of multiplication where things are just right next to each other, okay? So we want to use the area model here to multiply this. I could have made my little box thing, but this is actually cooler because it's green now. And I'm going to keep this up, try to remind me to keep this up and not erase it, okay? So we have our factors. I'm going to put a 6 and a 3i on the tops here, and a negative 2 and 4i here. So remember when we were factoring quadratics, we were doing the reverse. I had the multiplied togetherness of that quadratic that I put in here, inside the boxes of the area model. But in this case, I'm trying to get them together because I don't have them together now in terms of multiplication. So I'm going to multiply everything together here. So 6 times negative 2 is negative 12, and negative 2 times 3i is negative 6i. 6 times 4i is 24i, and 3i and 4i gives me 12i squared. But remember that I squared equals negative 1. So this is really saying 12 times negative 1, and the dog is barking again. How fun. And that's going to be a negative 12. So that's all going to go away. Now I'm going to combine like terms. Negative 12 minus 12 is negative 24. And 24i minus 6i is 18i. And that's my final answer. It is in the form a plus bi, so we're good. 16 is going to be negative 24 plus 18i. Okay, 17. Negative 5i times negative I times negative 6 minus 7i. Okay, a lot of crazy things are going on here, right? So this is not actually a binomial. So this is not the same type of problem that we just did for number 16. What we want to do first is we want to multiply this negative 5i and this negative I together. That's going to give me one single term. Negative 5i times negative I, and we could say that that's a negative 1i if that makes you feel better. This is 5i squared. Well, we know that I squared is negative 1, so this is going to be a negative 5. Now, that negative 5 is going to be multiplied to, or distribute to, the other set of parentheses here. Because that's a single term, I am only distributing that negative 5 to both terms. So there is no area model necessary. Negative 5 times negative 6 is 30. And negative 5 times negative 7i is positive 35i. Done deal. Again, no area model necessary for this problem. So it's going to be 30 plus 35i. Okay? Okay, number 18. 18 will require the area model. So 7 minus 2i times 3 minus 3i. All right, so again, let's use our boxes here that are actually really ugly looking, right? Because they're not, perfect. 7 minus 2i and 3 minus 3i. All right, 7 times 3 is 21. 3 times negative 2i is negative 6i. 7 times negative 3i is negative 21i. And negative 3i and negative 2i gives me 6i squared. We're just flipping that sign because remember, I squared is negative 1. So this is actually saying 6 times negative 1 or negative 6. So when I combine like terms, 21 minus 6 is 15. And negative 21i minus 6i is negative 27i. Final answer, 15 minus 27i. Okay. Number 19. Just be really careful when you're using the area model too, right? You know that one of these boxes is going to combine that I squared with a number. So it really is just multiplying by the negative 1 to finalize that part of the problem. So just be aware of that, okay? Number 19, all right. 4 plus I times negative 2 minus I. All right, again, area model, because I've got two binomials or two-term things. 4 and I, negative 2 and negative I. Negative 2 times 4 is negative 8. Negative 2 times I is negative 2i. Negative I and 4 gives me a negative 4i. And then negative I and positive I is negative I squared, or negative 1i squared. So that's going to be negative 1 times negative 1, or just 1. Combining like terms gives me negative 7, because negative 8 plus 1 is negative 7. And negative 4i and negative 2i gives me a negative 6i. Final answer is negative 7 minus 6i. Okay? Okay, I think there's only one more of this set, so we can erase this and just write it again. Because as you can imagine, dividing's a lot more in depth than this, right? Okay, 20. Good stuff. All right, number 20. Ooh, this is a good one. Negative 3 plus 5i squared. Now, don't get fooled by this one. We are not just distributing that 2 to both of those. That square, that 2 exponent, means there are 2 of these. So we are going to write 2 out exactly right next to each other. So 2 identical things, right? So this is going to be negative 3 plus 5i times negative 3 plus 5i, right? It's the same exact thing twice. Area model this out, right, is going to give me the same process again. Negative 3, 5i, negative 3, and 5i. Negative 3 times negative 3 is 9. Negative 3 times 5i is negative 15i. Negative 3 times 5i is negative 15i again. And then 5i times 5i is 25i squared, or negative 25. 9 minus 25 is negative 16. And my 2 negative 15i's combine to be a negative 30i. Final answer for number 20, which rounds out the multiplication part, is negative 16 minus 30i. And again, it wouldn't be mathematically incorrect if you switched the I and the constant value, but because that's not the format, right? We need A plus BI. This is proper, and this is mathematically and properly correct too. Okay. All right. Next set of problems are dividing. Yay. Okay. Let's do this. All right. Number 21. And we'll start with some single terms over single terms, and we'll go from there. 21. Three divided by 9i. Now remember, way too high up. You should have stopped me. I know you probably tried to. It's okay. Remember, when we're dividing complex numbers, it's a lot like rationalizing denominators with radical signs. Just like when we can't leave a radical in the denominator, I certainly can't leave I in the denominator either. It doesn't work that well. So I'm going to multiply by the complex conjugate or the conjugate, which is simply just the opposite sign of the denominator. That's a positive 9i. I'm dividing or multiplying it by a negative 9i. Now I have to do that to top and bottom. That's the purpose of this procedure. Like it has to be the exact same fraction on numerator and denominator. So when I do that and I multiply across, I get negative 27i. No, sir. No, sir. Stay there. He was barking, so I told him to stay. Now, 9i times negative 9i is negative 81i squared. This is negative 81 times negative 1, which is just 81. All right. Now, we need to see if there's some simplification we can do, and there is. Both of these terms actually are divisible by 27. And you can do this process the long way if you need to. Like you could recognize that there's a 3 I can take out or a 9. 27 is actually the greatest common factor though. So when I divide out a 27 on both top and bottom, I'm going to be left with negative I over 3. So my final answer for number 21 is negative I over 3. Okay. And again, the simplification part of this is probably going to be the biggest challenge for you because those numbers didn't look like they were simplifiable, but clearly they were. 22, negative 9 over negative 8i. Okay. Negative 8i is the denominator. I'm going to multiply by the complex conjugate, which is a positive 8i on both top and bottom. This is negative 72i over negative 64i squared, which is just 64. Now, what do these have in common? Well, they were both multiplied by 8, so I could probably take out an 8. So let's see what that looks like. If I divide by 8 on top and bottom, I get negative 9i over 8. Now, it's interesting how it's the same kind of value that's there. I just switched the I. And that is something that we do see very often because that's the purpose of this. Don't put too much stock in just trying to figure it out by here. Do the mathematics, do the algebra to get it right all the time, right? Don't try to guess about what it's going to be. Make sure you do the algebra out to get that right. So my answer for number 20, this is 22. 22 is going to be negative 9i over 8. And again, I can be in the numerator. It's fine in the numerator. It's when it's in the denominator that makes a big mess, right? 23. 6 divided by negative 5i. Complex conjugate is positive 5i, so 5i on top and bottom. That's going to give me 30i over negative 25i squared, which is just 25. They both have a 5 in common. 6i over 5 is my final answer. So 23 is 6i over 5. Okay. 24, I think there's 2 more in this set, and then we go to binomials in the denominator. 3 over I. That's a positive I. We actually did this a second ago in terms of the complex conjugate only. So if I have an I in the denominator, I'm going to multiply by negative I on both top and bottom. That's going to give me negative 3i over negative I squared, which is negative 1 times negative 1, or 1. Now, we don't have to write that denominator when it's 1, so my final answer is just going to be negative 3i. All right, 25. Last one of the singles. I couldn't make this up. The program actually just did that. So the last problem we did was 3 over I, and it's literally right in front of me. And the next one's negative 3 over I. How stupid, right? All right, so this is a negative I and a negative I. All right. This is 3i over, again, negative I squared, which is negative 1 times negative 1, which is 1. So this answer is 3i. I don't have time to make that stuff up. Okay. All right. Now that wraps up the monomial, which is one term, over a monomial, which is, again, another term. So number 26 starts the process of monomials over binomials. So let's go ahead and start those. So number 26 is 2 over 4 plus 2i. Now, this is really the true complex conjugates. I am just switching the sign in the middle to multiply by top and bottom. So this is going to be 4 minus 2i and 4 minus 2i. Now again, when we divide these things, it's really way more multiplication. It's like actually no division, right? So it's a little misleading. So we're going to distribute that 2 to both terms on top. this is going to be 8 minus 4i. That's the top. Now, the bottom, I will do a longer one in a minute, but the shortcut here, because we're multiplying by the conjugate, what's happening is the two middle terms are going to cancel out. That's the purpose of multiplying by the conjugate by the opposite sign. So we can get rid of that I term that would be simplified in the middle. Here, what we want to do is just first times first, which is 16, and then the last two terms together too, the I parts together. That's going to be negative 4i squared or positive 4. Now again, on the next problem, I'll show you the area model part of that, and we can go from there. So this is going to end up being 8 minus 4i over 20. But all three terms are simplifiable. They all have a 4 in common. So if I divide by 4 on all three of those terms, 8 divided by 4 is 2, 4 divided by 4 is 1, or just I, and 20 divided by 4 is 5. So my final answer here for number 26 is going to be 2 minus I over 5. Now, you might be asking yourself, well, it's really not an a plus bi form. Well, when there's a denominator, it doesn't have to be, because the denominator kind of throws off that numerator part. So it's okay if it's not exactly in that a plus bi form. Now, that one is, but ones in the future may not be, and that's totally fine. Okay? So that was number, I just want to make sure I'm on the right one, 31. 26 on this one now. So we'll do about 5 more of these, and then we'll get to 31. All right, 27. 8 over negative 5 minus 9i, okay? Again, only switching the middle term. Now, I'll do this one the long way so you can see what I was talking about before. This is going to be negative 5 plus 9i on both top and bottom. Now, I don't have to area model the top, obviously, because that's just distributive property from the 8. So the top is going to be negative 40 plus 72i. Now, the bottom, let's area model it so we can see what happens here. And then hopefully we won't have to area model it again. Negative 5 minus 9i, negative 5 plus 9i. All right. 25. Positive 45i. Negative 45i. Sorry, my brain actually just stopped working for a second. Did you see that? And then 9i and negative 9i is negative 81i squared, or 81. Here is the reason. These two diagonals are the reason why we don't have to FOIL or area model this thing out. Because 45i minus 45i cancel completely. So all we're left with is the 25 plus the 81, which is going to give me my denominator of 106. Okay. Now, they obviously have something in common. They at least have a 2 in common. So let's divide by 2 everywhere, because I don't really know where else we can go from there without using my calculator. Dividing that by 2 is going to give me a negative 20. Dividing this by 2 is going to give me a 36i. And dividing this by 2 is going to give me a 53. That's probably the answer, because 53 seems prime. Let's see. It is. So remember what we talked about in a previous video. All three terms need to be simplifiable, or they're not going to be able to be simplified at all. These were by 2. Now, I know you're saying the 20 and the 36 are simplifiable, but we're not allowed to pick and choose, because that 53 stops it. Either they're all simplifiable or they're not. So my final answer for 27 is what we see there, negative 20 plus 36i over 53. All right. So again, area models here. Now that we know it cancels, it's going to cancel 100% of the time. We don't have to do that ever again. Okay. Now, if you want to area model the denominator, be my guest. It will certainly make sure you get the right answer. It will be a lot more time consuming though. Okay. 28. 5i over negative 1 minus 5i. Okay. Complex conjugate is negative 1 plus 5i on both top and bottom. Distributing, now it's going to be a little messy because I got an I up here too. 5i times negative 1 is negative 5i. 5i times 5i is 25i squared, or 25 times negative 1, which is negative 25. Now again, I don't have to area model it. Negative 1 times negative 1 is positive 1. Negative 5i times positive 5i is negative 25i squared, which is positive 25. This is going to become negative 5i minus 25 over 26. Can't go any further. They have nothing in common. All right. So number 28, negative 5i minus 25 over 26. Okay. We're moving. I think we're moving fast. If it wasn't for me having to get the dog 15 times, we would be done by now. Which you didn't see because I'm editing that part out. 29. Okay, 10i over 6 minus 10i. All right. Complex conjugate is 6 plus 10i on top and bottom. Right? So multiplying out again, I'm distributing that top part. So 60i. 10i times 10i is 100i squared, or negative 100. And that's going to be over 6 times 6, which is 36. And this is negative 100i squared, or positive 100. Okay, this is going to be ugly. 60i minus 100 over 136. They definitely have a 2 in common, right? So let's do that. 30i minus 50 over 78. Is that right? No. 70. 68? Ew. Let's divide it by 2 again. 15i minus 25 over 34. That looks terrible. Is it right? Is it right? It is right. Ew. What a terrible problem. What did we want to take here? Because 2 wasn't good enough. Oh, 4. Greatest common factor here was 4, because 60 divided by 4 is 15, 100 divided by 4 is 25, and 136 divided by 4, which no one has ever done ever in the history of mathematics, right? So if you're struggling, as I just did, pick the thing you know they can be divisible by, which is 2, and then do it again, right? So this is my final answer. So number 29, I'm going to run out of space. So 29 is 15i minus 25 over 34. This looks like a problem you would have given me, Titan. Like, who simplifies 136? I don't think I've ever simplified 136 my entire life, buddy. Keep chewing that bone. Is it a good bone? Good. That bone costs $5. I'll be chewing for like a year. 30. Last problem with a monomial over a binomial. 2i, huh, what? You're talking back a lot today. You're talking back a lot today, buddy. With a $5 bone in your mouth, too. Negative 7 plus 7i, yeah, is the complex conjugate. Distribute the 2i on top. Gives me a negative 14i. 14i squared is negative 14. Negative 7 times negative 7 is 49. Negative 7i times positive 7i is negative 49i squared, or positive 49. This is going to be negative 14i minus 14 over 98. Ugh. They definitely have a 14 in common, hopefully. So let's divide 14 out of everything. This is negative I minus 1 over 7. Ooh. Is that right? Ew, it is. I just happen to know that 14 went into 98. Like, that felt right. So I could have used the calculator. Use the calculator. Don't do what I just did. I'm a trained professional. Sort of. Okay, negative I minus 1 over 7. That's a terrible one. The last 2 problems are really bad. I'm glad we're done with that section. But the next section's worse. Okay, so 30, right? 21 through 30, that was our 1 over 1s and then our 1 over 2s. So number 31 is going to start my next section, which is a binomial over a binomial, meaning a 2 over a 2. All right, so let's put 31 right here. All right. 31. These are going to take a while. I'm glad we have time. This is 3 plus 10i over 4 plus 6i. Okay, now again, complex conjugate all the way. That's the first start to this problem. I'm going to multiply both the top and bottom by 4 minus 6i and 4 minus 6i. Now, it's actually easier to do the denominator first here. When the last set of problems we were doing the numerator first, because the denominator doesn't require the area model here. 4 times 4 is 16, and then positive and negative 6i together is positive 36. Now, I have to area model the top because I've got 2 different sets of binomials. So 3 and 10i and 4 minus 6i. Hopefully you won't have too many. This is doing one setting. I think I have 5 to do. 12, 40i, negative 18i, negative 60i squared is just 60, okay? So combined like terms gives me 12 and 60 is 72, and then negative 18i and 40i is positive 22i. Okay, let's shore this up. 72 plus 22i over 52. I know they've got a 2 in common, so let's divide 2 out of everything, which gives me 36 plus 11i over 26. And that's probably my final answer. And it is. So final answer here, because I can't, again, pick and choose. That 11 throws a wrench into everything for us. So this is going to be 36 plus 11i over 26. Okay? So again, area model the top, but shortcut the bottom so you don't have to do 2 sets of area models. Again, you can do the area model twice if you want to. I would not. I would try to avoid that at all costs. All right, number 32. Negative 1 minus 10i over negative 8 minus 3i. Okay, complex conjugate is negative 8 plus 3i and negative 8 plus 3i. Bottoms are easier here, so I'm going to have a 64 and a negative 9i squared, which is just positive 9. Area model the bottom. Negative 1, negative 10i, negative 8, positive 3i. 8, 80i, negative 3i, negative 30i squared, which is just 30. Okay. Combined like terms gives me 38 plus 77i. This gives me 38 plus 77i over 73. There's no way they have anything in common, because 73, I think, is prime. So my final answer for 32 is 38 plus 77i over 73. And let me check that, because I would hate to. Yeah, that's right. Okay. Hate to write something down that's wrong. I've actually done that a lot this year with these problems. Isn't that stinky? Isn't that stinky? 33. 2 plus 3i over 8 minus 8i. All right. Ooh. Complex conjugate is 8 plus 8i and 8 plus 8i. Denominator is going to give me 64. Negative 64i squared is positive 64. Area model. 2 and 3i and 8 and 8i. 16, 24i, 16i. 24i squared is negative 24. Combining like terms gives me a negative 8 and a 40i. Simplifying through gives me negative 8 plus 40i over 128. All right. This one I'm actually going to divide by, because I want to make sure it is what I'm thinking it is. Okay, we're going to divide 8 out of everything, right? So dividing 8 out of everything gives me negative 1 plus 5i over 16, which is the final answer because I can't simplify any further. So number 33 is negative 1 plus 5i over 16. I wanted to do 2 more. Let's get 2 more in here. Let's see where we're at in terms of time. 34. 3 minus 6i over negative 8 plus 5i. Okay. Complex conjugate is negative 8 minus 5i, so that on top as well. Bottom, 64, again, that's weird. And then negative 25i squared, which is positive 25. Area model, though, top. 3 minus 6i, negative 8 minus 5i, negative 24, plus 48i, negative 15i, 30i squared is negative 30. All right. Combine like terms, that's a negative 54. and a positive 33i combining like terms on the bottom will give me 89. Ooh. They don't have a 2 in common. They don't. Oh, do they have a 3 in common? I don't think they have a 3 in common. That's it, actually. That's the answer. And you would go through the process in the calculator, right? You know it doesn't have a 2 in common because we have an odd and an even number. 3 doesn't work either because it won't fit into 89. It does work for the other two. 4 doesn't work, 5, and you would go from there, right? And that process might take some time, which is okay. Negative 54 plus 33i over 89 is my final answer, okay? Last one of this set, and then we'll move to something else. I think it's powers of I, which isn't too bad. 35. 6 plus 9i over negative 2 plus 9i. Okay. Complex conjugate is negative 2 minus 9i. So negative 2 minus 9i on top as well. Multiplying the denominator is 4. Negative 81 squared is positive 81. Area model the top. 6 plus 9i, negative 2 minus 9i, negative 12, negative 18i, negative 54i, negative 81i squared is 81, okay? Negative 12 and 81 is, I hate 1s and 2s. I hate subtracting 2s from 1s in double digits. I think that's a 69. Right, because 71, yeah. And then we have a negative 72i. This one's terrible. Okay, negative 72i. Let's combine like terms. 85, is there anything in common? Those numbers are horrible. Those are really high numbers. That's actually the answer. Ugh. Okay, so number 35, our final answer for this set. 69 minus 72i over 85. Big, big, big numbers. You see how we can kind of really go up and down in terms of these numbers. Okay. Next set of problems, 36 on at least until 45, is powers of I. 36. Evaluate, meaning just simplify maybe? That's kind of a better word for it, right? So we're going to evaluate I to the 6th power. Okay, well, we know the rule. So I to the 6th can get rewritten, and that can be I squared in parentheses, and then whatever, how many times 2 fits into 6 through multiplication. So we're going to divide. 6 divided by 2, and that's 3. That gives me 6, so I'm not multiplying by anything else on the side here. And the reason we do this is because we know what I squared is. It's negative 1. Now, this is really saying negative 1 to the 3rd power. Anything to an odd power is negative 1, meaning negative 1. So my answer is negative 1. Okay? Now again, when we raise negative 1 to an odd power, it's negative 1. When we raise negative 1 to an even power, it's positive 1. The only change is when we have an odd originator, or like the odd start, okay? So 37. I don't know how this is going to work, so let's see. I to the 8th. Okay, and this is one of those sets of 4 that we talked about in another video, but it's not really going to make much difference for us. This is I squared to the 4th, or I squared to the 4. This is called the power rule in exponents, where 2 times 4 is 8. Now, if we were adding them together, it'd be a little different, but because we have a parentheses here and we're raising it to another power, it is multiplicative in nature. So we can rewrite it like this. This is negative 1 to the 4th power, which is just 1. So 37 is just 1. Now remember the 4 types of answers you're going to get with these things. You're going to get I or negative I and 1 or negative 1. There is no other answer when there's no coefficient, okay? Coefficients make it a little messier, and I think there's a couple of them on here that we can talk about. So 38 is I to the 3rd squared times I, right? So then we have a negative 1 times I, which is negative I. So for number 38, we have a negative I. Okay, I got tripped up on that one. Number 39, because the process is weird on that one. Okay, number 39, I'm going to skip ahead a little bit. Let's do I to the 15th power. Okay, well, I can rewrite this as I squared, and then I can't divide this because it's going to give me a decimal, right? But 14 I can divide by 2, and that gives me 7. Now, because it's odd to start, I'm going to get an even result through the multiplication here, but I have to multiply it by a separate I, or what we call a remainder I, right? Because I squared to the 7th power is I to the 14th times another I is I to the 15th. This here represents the 15 i's that were here. So again, we know that this is -1 to the 7th power times I. Well, -1 to any odd power, again, is -1. Times I again is going to give me a negative I. I want to make sure you can see this. 39 is negative I again. Okay. And then number 40 I'll put up top. I to the 20th. Okay. So this is going to be, again, I to the 2nd power. Now, I'm going to just put a power of 10 there because 2 times 10 is 20, or 20 divided by 2 is 10. No remainder necessary. So I squared is -1, and to the 10th power, which is even, yields me a 1. So for number 40, we have a positive 1. All right? We're going to do 5 more like that because some of them are coefficients, and then we'll finish off with some mixture problems. Oh, we're going to be on 41. We're almost done. Not bad. All right, 41. Oh, my eye itches. Ah! Okay. Yes, I do that because I don't want to touch my eye with my hand. Okay. I to the 225th power. What are you doing? Okay, well, hi. I squared. Now, let's make that 224, right? So what's 224 divided by 2? 112. 224 divided by 2 is 112. But that's 224. I have to account for the other I, right? So I squared is -1, and I squared to any power that's even is 1 times I, which is I, right? So it doesn't matter how big the number is, right? As long as you know that it's even or odd, who cares what the number is? You can just tell me what it's going to be when I have -1 here. So number 41 is just I, right? So it doesn't matter the size of the number. Okay? 42. I to the 1078th power. Cool. Okay, so again, don't stray from the process. This is I squared. I just want to divide it in my calculator. So what is 1072 divided by 2? And it's 539. Okay. No remainder though, right? Because this is an even number. So this is -1 to the 539th power. 9 is odd, which means I have a -1 result. So 42 is a -1. Right? It doesn't matter how big the number is, right? That's ridiculous, by the way. I don't know why in any way you would raise something to a 1,000th power. In terms of I, in terms of like your math class. Okay, number 43 is I to the 33rd. Okay, I squared. 32 is what I want, right? Because that's even. And then times an I, like another I, right? So 2 times 16 is 32, and I account for that other I. Because this is like I to the 1st, right? But we don't put the 1st because that's weird. So this is -1 to the 16th power times I. Even power, so 1 times I, which is just I. Right, so number 43 is just I. Okay, 2 more like this. And I think both of them are coefficients. 44, 8I to the 19th power. Okay, so a coefficient's a little different, obviously, because we have another value here that we have to account for. But really and truly, our focus is still on the I to the 19th power. We'll multiply the 8 later on once we're finalized with what we want. So let's do that. Let's gonna make this 8 times I to the 19th, and let's forget about that 8 for a second. So we're just gonna make a little arrow going there. I to the 19th is gonna be I squared, but I want 18, right? Because I can't divide that evenly. So 18 divided by 2 is 9 times I. So this actually says 8 times the quantity of I squared to the 9th power times I. So this is 8 times -1, keep it in parentheses, to the 9th power times I, or 8 times -1, because I have an odd power, times I, or -8I. So my answer for 44 is -8I, right? So we have a succession here. We have a step-by-step process. Just keep bringing stuff down and simplify one level at a time. If you can do this in your head, you're better than me. I got nothing else to say about that. If you can do it in your head, you're better than me. Because if I was doing this off to the side, I would be doing this on paper. Last one, 15 I to the, really? If this wasn't on like a piece of paper that I printed, Titan, I would have blamed you for this. I would have blamed you for making this. Like, who does that? 15 times, another Titan here. I squared. All right, now 1200 divided by 2 is 600. But I have to account for that other I. This is ridiculous, man. 15 times -1, keep it in parentheses, to the 600th power times I. 15 times 1, because it's even, times I is 15I. Ooh. Ridiculous. Totally ridiculous. 45 is 15I. I really messed this whole thing up. I'm getting tired probably. 45 is 15I. Write the 5 out. Okay. All right. Next 5 problems, or the last 5 problems, looks like a little bit of a mixture, but I'll keep it on part 4 for now. Okay. So, interesting. Number 46. Find the sum of 7 plus I and 7 minus 2I. Okay. Adding or subtracting problem for sure. Sum means addition, so plus. So I'm just going to rewrite this in terms of what the sum means. Sum means add. So this is 7 plus I plus 7 minus 2I. Drop the parentheses and move from there. 7 plus I plus 7 minus 2I. 7 plus 7 is 14. 1I minus 2I is -1I. So number 46 is 14 minus I. So when we see the word sum, we mean addition. So just write it as addition, okay? I think you know what the next one's gonna be, but it's gonna be written really weird, and even I get tripped up on these. Subtract 18I minus 4 from 8I minus 1. Okay, this is not as straightforward as it seems. Certainly we are subtracting, but this word from is extremely tricky. I want to subtract this from that, meaning I'm taking this away from that, meaning this has to go behind and this goes in front. The word from here is super tricky. When you see the word from, first of all, we know it's subtraction. When you see the word from, the second thing has to move to the front. So this is actually going to be 8I minus 1 minus 18I minus 4. Huge, huge, huge. If you don't switch these, you will subtract incorrectly, because I don't want to take this away first. This needs to be behind it because I'm taking this from that. Right? If I'm taking money from you, I'm going to you to take money away, right? So it's like you minus me. I think I said that right. All right, distribute the minus sign. 8I minus 1 minus 18I plus 4. 8I minus 18I is -10I. -1 plus 4 is +3. But remember, this is not in the right format. This needs to be 3 minus 10I. This problem was awful. We'll do another one like this. I'll make one up. So 47 is 3 minus 10I. Oof. Gotta be careful that word from, okay? Again, I'll make one up real quick. That problem is terrible. That sucks. Okay, let's say subtract 2I minus 8 from 15 plus I. Again, I'm subtracting this from that. This comes after that. This comes first. 15 plus I minus 2I minus 8, right? We are flipping these around, right? Distribute the minus sign. 15 plus I minus 2I plus 8. 15 plus 8 is 23. I minus 2I is -I. It is in the correct format, so 48 is 23 minus I. Be very careful about these problems for sure. Why did I say 46 still? That was 48. I got 2 problems left. Oh yeah. Okay. Ooh, here's a good one. 49. Find the product of 10i plus 2. Oh, it doesn't say that. It says and. Okay. And 5 plus 5i. All right. Product. Well, sum is addition. Difference is subtraction. Product is multiplication. So I'm going to rewrite this, and the order does not matter. So 10 plus 2 times 5 plus 5i. We're going to area model. 10i and 2, 5 and 5i. This is 50i, 10. 50i squared is negative 50, and 10i. Combine like terms, 50i and 10i is 60i. And negative 50 plus 10 is negative 40. But it's in the wrong format, right? It's got to be a plus bi. So this is going to switch around, negative 40 plus 60i. That's my final answer there. One more. I always get very excited when there's one more left, huh? Okay, let's see what we got. I feel like I saved the worst for last. Powers of I problem. 7i to the 7th plus 8i to the 80th. I'm sorry. We're just going to simplify it, break it down to what we know, and then add whatever those things are together, right? So our number at the end of this process is going to be very low, probably. Let's see. Let's do the first part. This is 7 times I squared. And remember, 7 doesn't work, so I need 6. So this is going to be 3 times I. That's what this term comes to be, right? Plus, let's break down this term. 8 times I squared to the 40th, and that fits nicely. We are going to break this down step by step. So this is our first step. We just want to rewrite or reevaluate what these larger numbers mean. Now I've got 7 times negative 1 to the 3rd power times I plus 8 times negative 1 to the 40th power. I'm certainly going much faster than you should on your first attempt, but you understand the process here, I think. 7 times negative 1, because I have an odd power, times I plus 8 times 1, because anything to an even power is 1. Now let's combine. 7 times negative 1 is negative 7 times I is negative 7i, and then plus 8 times 1, which is 8. Final answer, but it's in the wrong form. 8 minus 7i is my final answer. Last problem's answer was a doozy. 8 minus 7i. Hopefully you don't see too many of those, right? But it's the same process. Just pretend like you're breaking down one at a time, and we'll go from there. Thanks for watching this episode of TitanClass. See you next time.